This is the solution video for question 32 from part B of the 2019 ECAA paper. In this question, we're asked to consider the following function f of x equal to p to the 2 over 3 x cubed plus px squared plus p to the 1 over 3 x plus 3, where p is a positive constant. And we're told p is such that the derivative of f equal to 0 has exactly one solution. Given this information, we're asked what is the value of p, and we're given 6 different options. The key thing to realise about this question is we don't really care about f of x. What we really care about is f dash of x. So we're looking at f dash of x is equal to 0. So let's work out what f dash of x is. So we have 3p to the 2 over 3x squared plus 2px plus p to the 1 over 3. And we're looking at when this is equal to 0. And what do we want? Well, we want a p so that there's exactly one solution to this. So what is this? Well, it's a quadratic. So if we've got a quadratic, we know that if there is exactly one solution, then the discriminant has to be 0. So let's look at the discriminant of this being 0. So that's saying 4p squared, so b squared, minus 4a, which is 3p 2 over 3, c, p to the 1 over 3, here is equal to 0. And it's quite nice because the p times 2, p to the 2 over 3 times p to the 1 over 3 is p. So we get 4p squared minus 12p is 0, and we can take a factor of 4p out of this. 4p plus p minus 3 is 0. We have to be a little bit careful here now though, because we can spot that p is 3 as a solution, which is the 1 here, but also p equals 0 as a solution. So how do we sort this out? Well, let's look at what p equals 0 does. If p is 0, then this is just 0 for any x, right? Because we've got 0x squared plus 0x plus 0. And that doesn't mean we have one solution. That means we have infinitely many solutions, because any x works. So p equals 0 is not the one we want. And so by a process of elimination, we know p must equal 3. And if we sub p equals 3 in here, you see you don't get a 0 quadratic. You get a real quadratic with non-zero numbers behind all the x's. But in any case, p equals 3 is our solution, and that matches option E in a multiple choice. So our answer is E.